critical components are developing every day as we speak, people tend to overlook the fibres themselves. And I'm talking today to Robert Lingle of OFS. Robert, you've just spoken at the Market Focus here at ECOC. Tell us why we need new fibre.
Well, Brian, the systems companies have given us tremendous increases in capacity and what we call spectral efficiency over the past 10 years. And people often assume that that can just go on forever. The reality is that there is a 50 gigahertz ITU channel, and the spectrum is about to bust out of that in the future. And so in the past, we've been able to go from 10G to 100G to 200 and 400G, and the capacity just keeps growing. The reality is that when we go from 100G to a terabit, you're only going to get 4 times as many gigabits per second. So the speed's going to go up by 10, but the capacity is only going to go up by 4. And it's not going to grow after that at all. So one of the things that is available is to make sure that as we lay new fiber and cable, that we have better fiber, which can help support the higher spectral efficiencies going farther. Again, as you say, it's kind of overlooked, but it's about to become a big issue.
What are the developments so far? How is progress going?
Well, we've been working on this problem for 4 or 5 years, 6 years. Started in the submarine market, but it's becoming important in the terrestrial long-haul market now. What we learned is that coherent transmission is very sensitive to nonlinearities, as well as loss. But you really need to increase the size of the mode field, or what we call the effective area of the fiber, as well as push the loss down. When you do both of those, you get an additive effect, and you get better OSNR for the link. And that helps you to transmit 100G. Well, 100G goes a long way, but when we go past 100G, that's where you really need better fiber, better cable. And so this greater OSNR that the fiber and, for example, a hybrid Raman amplifier provide are extremely useful. You can push 16 QAM, which is 200 and will be used for 400 gigabits. You can push 16 QAM to 2,000 kilometers without a regenerator, where it would only be maybe 500 or 600 with standard fiber. You can push 150 gigabit 8 QAM to 4,800 kilometers optically, end to end. So these are really big advantages if, for example, you're a cloud data center company and you're pushing huge volumes of traffic over long distances.
So are you confident that fibre can continue to meet this incredible demand we're seeing?
Well, so that's a very good question. People have proposed a lot of exciting and, I should say, exotic technologies for breaking out of the barriers. Fiber with multiple cores, fiber where you would transmit over multiple modes, air core fiber. I think I would leave it, to answer your question, to say there's a lot of capability and possibility there, but practically and economically, there's still many hurdles to jump over to make those technologies practical. Right now, as best we can foresee, it's important to make sure you still have a very high quality cable plant with at least a component of advanced fiber in it, so that as the demand keeps growing exponentially, you're going to be able to transmit these higher order coherent modulation formats at distances that remain economical.
Robert, thank you very much for talking to us.
It was a pleasure, Brian. Thank you.